Okay, next section says atomic mass and isotopic or percent abundance. And basically what this is it's using data, and they might say something like it's from a mass spectrometer, and we'll talk about that in a minute, but a mass spectrometer is an analytical device that can give you information about a sample. So we can tell you in a sample how much of your sample weighs a certain amount. So in this case, 75.53% of our sample weighs 34.97, and 24.47% of our sample weighs 36.97. Now, again, IB likes to talk about a mass spectrometer, but that's not a device that we're going to be able to have in a high school or probably most educational settings outside of a college environment. So anyway, going to do a little bit of math, but here's what you're really looking at is that if you look here at the periodic table, we're just finding or verifying these values, right? So you have all of these different values that we could be trying to find or verify. So that's kind of what's going to be going on with this. So let's just take a look at the math. And so this one just gives us everything we need. Very, very easy. You did this, or should have done this in your 10th grade course. And so basically what this formula says is you take the mass of your first chemical times the percent plus the mass of the second chemical times its percent, and you just do that as many times as you need in order to solve your problem. So like they'll give you 2 or 3 or 4, and you just do the math. So let's run it through real quick. We'll take, chlorine 35, and they're saying that the chlorine 35 weighs 34.97. So we'll take that 34.97 and we'll go ahead and multiply it by the percent. And so 75%, of course, in your calculator, you're going to move the decimal 2 spots to the left. So it's going to be 0.7553. And then we're going to go ahead and put a bracket around that because we want to do all that on our calculator first. And then we'll just add it to our second piece of data, which is the chlorine 37. So interestingly, chlorine 37 coming in at 36.97. Now the AMU is atomic mass unit, and that's the same as grams per mole, which is probably what we're a little bit more comfortable with. So then we'll plug this in, 36.97, and we'll go ahead and multiply that by the 24%. But we got to move the decimal, so let's fix that real quick. And there we go, 0.2447. Now, if you did what I almost did there, where I made a mistake, then you're going to get an odd value, and we should talk about that real quick. Anytime you're doing one of these averages, you know that your answer has to be between the high and the low. So the low is 34.97 and the high is 36.97. So it has to come in somewhere in that range or the answer's wrong. And so we'll just slide this up a bit and then we'll drop our answer in right here. Okay. So let's go ahead and run this through our calculator. So just do it real quick with you. So 34, let's plug in 34.97, multiply it by 0.7553 on your calculator, hit enter. Go ahead and hit plus, and then inside of parentheses, do your 36.97 times your 0.2447. Close your parentheses. And you should get a value of 35.4594, which is definitely within our range, right? It's above the low, it's below the high. These have this one has 4 sig figs, as does this. So then you could report an answer of 35.46. So we can double check. We know it's chlorine. They already told us that, right? So they said chlorine. So if we just look at our periodic table and we find chlorine right there, 35.45 on our periodic table. So pretty close. And so that should be good enough. Now, what the next thing is that you end up looking at problems, and of course IB is like this where you never get the easy problems. So if you look, now what they're doing is we're finding the percent abundance. And so what that is that you're going to either you're finding one of these values, right? So you're going to find the percentage. And so instead of them giving us the percentage, which is pretty easy, we have to find that percentage. So students sometimes have difficulty with this problem, but really it's pretty straightforward if you just kind of pay attention to where you're plugging in your variables. So what I tell students is right here, assign the heaviest value, a value of x. So in a situation above, I would have given the x to the chlorine 37. So the 36.97, it would have been the x, so that the heavy value gets the x. And then the remainder is 1 minus x. So if you think about the one above, it has to be a total of 100%, right? So if we have 100% and we know that 24.47% is one of them, then the remainder has to be the other. So let's look at this problem. Now, I will note that on the problem below, it is more likely that they give you sort of a mystery chemical than they do a chemical with like a name like copper or nickel or whatever, but not a big deal either way. So we're going to take x and we're going to assign x to our heavier value. So that's going to be the x. And so then we're going to kind of run through this and show you how it works. And so it's basically going to be at the heavier value, and we're going to take that percentage plus the 1 minus x percentage, and it's going to give us what we need at the end. So let's run it through real quick so you can see it. So we've got copper 65, and copper 65 is going to weigh 64.9278. So I'm going to assign that value to x because it's heavier. So I'm just going to go ahead and plug in 64.9278 and then an x. So like the x, that's the heavier one, all right? Then we're going to add that to the other one, which is going to be assigned the value of 1 minus x. And so let's go ahead and do that so that the lighter one is the 62.9298. Now, you're not going to ever be able to solve this if they give you more than 2. So this is always just going to be 2. So let's go ahead and do that. And so it's 9298. And then I'm going to assign that a value of 1 minus x. And then I'm going to set this whole thing equal to what it weighs on the periodic table. And they conveniently told us that it weighs 63.546. Now, you need to make a note that if they do not give you this number, if they do not tell you what it weighs on the periodic table, then you can look that up. So you can look this value up. And a lot of times they don't give you that number. So you just have to look that up on the periodic table. So just because they don't give it to us, it's not like we can't go to our periodic table. 63.546 is what they're saying for copper. Well, we can go to our periodic table and we can find copper 63.55. So we could have found a value very close and been fine. All right, so what I'm going to do is going to set this equal to that so that 63.546 is going to go here. All right, so at this point, now we're just going to solve the problem. So you are simply solving for x, and so you're going to end up running this through, and it's going to end up, this is going to get kind of tight, so I have to write a little bit small here. So this is going to be 64.9278 x, and then we're going to add that to 62.9298, see I multiplied by 1, minus 62.9298x, and then we set that equal to 63.546. And again, now you're going to solve for x, and so we're going to run that through. So when we add these up, what you're going to get is 1.998x, and that's going to be 6.9278 minus, see, we would subtract this one minus that one. That's where I got the, took this minus this, and that's where I got the 1.998x. And then we're going to take this 62.9298, and we're going to subtract it from 63.546 because I want it on the other side of the equation. And so when I do that, 1.998x is going to equal the remainder, which is 0.6162. All right, solve for x. So obviously x at this point is just going to be 0.6162 divided by 1.998. And we're going to multiply that by 100 in order to get a percent. And once you go through all of this, you're going to end up with an answer. I'm going to slide down here because I'm running out of space. And so we'll put our answer down here. So we run that through, and you're going to get not 0, because I've already multiplied by 100. I'm going to actually get the percentage now. It's going to be 30.84%. Okay, now this percentage goes with the heavy one. So the heavy one was going to be the one that weighed 65, right? So that is the copper up here. These are copper, so that's the copper 65. So the copper 65 we know is 30.84%. So that means that the copper 63, which is the other one, is just going to be the remainder. So the remainder, we just go 100 minus 30.84, and that gives us the remainder. And we run that through, and we're going to get the remainder, which is the 69.16%. So if we go back to the problem, what the heck did they want? It said, what must the natural abundances be of the two isotopes? That's what they were looking for. So here we go. The copper 65 is at 30.84, and the 63 is at 60.916. What students struggle with the most is that whatever the answer is, that is the answer to the heavy one because you set x equal to that. And so that's why that was the copper 65, because of course that's heavier than copper 63. All right, so try example number 3 on your own, and then I'll clean this up and put the answer for number 3 on there. Okay, so there it is. Worked it out for you. You can notice this is significantly easier because boron 10, the only value you have to go with is 10. So they didn't tell you a different one, so it weighs 10. And boron 11 weighs 11. So I just set the heavier one times x, so 11x, and then the lighter one, 1 minus x. The math is super easy because 11 minus 10 is 1, so you don't even have to divide. So x equals 0.81, which that's going to convert into 81%. So that's super straightforward. And then the second one would be 100 minus 81 for 19%. Just remembering that the heavier value is going to be the one that gets the answer. So stop the video here because we're running out of time.